Today we will be learning some basics about the lithium ion battery. Everyone knows that nowadays a lot of lithium ion batteries are used in the upcoming electrical vehicles, whether they are two-wheelers, three-wheelers or four-wheelers. So today we will be having a brief discussion about the lithium ion batteries. So primarily lithium ion batteries are available in two chemistries. One is lithium nickel manganese cobalt oxide LiNiMnCO04, or in basic language we also call them NMC batteries. Second is lithium iron phosphate battery LiFePO4 battery, or in general language we call them LFP batteries. So they both these chemistries are used in the vehicles. NMC being an initial technology. NMC was the when the lithium-ion batteries started being used in the electrical vehicles. NMC was the initial technology. Now, on use of NMC, there were few disadvantages seen, and after that, new technology of LFP battery came into being. So, we have some basic advantages over NMC in LFP, which we will be discussing in the further slides. So, before we go further, let's understand the chemistry in a battery. So, as every one of you know that there are the basic uh, in a battery constitutes of an anode, the negatively charged electrode, and the cathode, the positively charged electrode. So if we talk about lithium ion batteries, so at and there are two cycles, one half reaction that takes place at anode and another half reaction that takes place at cathode. So at the cathode, which is made up of LiCOO2, and anode, which is made up of graphite. So initially in first half reaction, the lithium cobalt oxide breaks up into cobalt oxide and lithium ion and an electron. These lithium this lithium ion travels through electrolyte to anode, and electron travel through external circuit producing electricity. This is in case of discharge state, when the battery is discharging. After the reaction has taken place and lithium ion has moved to anode, in this condition the battery gets fully discharged. Now, when we apply an external source for charging the battery, so in that case, what happens is the lithium ions again moves on to the cathode, and electron moves through the external circuit. The electricity which is applied to the through the external circuit. So at when the battery is fully charged, the cathode comes into its original chemistry, that is LiCOO2, and the pure graphite, the anode is left in the form of graphite. So this is the process through which charging and discharging happens in lithium ion batteries. So moving forward, these are the three types of cells. Primarily, these are the three types of cells that are being used in when we want to make any battery pack. First one, you can see they are in the cylindrical form, also known as cylindrical cells. Second is prismatic cells, and third are pouch cells. So if you talk about their application, cylindrical cells both can be NMC or LFP type, and they are generally used in the batteries, two-wheelers, three-wheelers, even for four-wheeler batteries. Prismatic cells being they have higher capacities. Their age is higher, and they are mostly in form of LFP, and they are mostly used for four-wheeler batteries. Pouch cells, if we talks about pouch cells, are mostly used in the electronic items. Maybe if it we can say mobile or in laptops. So if we this is primarily the features of an NMC cylindrical cell. So if we talk about NMC cylindrical cell, they are available into various sizes: 18650, even 18650, and in 21700 form. What this number signifies is the first two digits signifies the dia of the cell, and the second two digits signifies the length of the cells, all in millimeters. So if we talk about the typical capacity of NMC cylindrical cells, they ranges from 2 to 2000 2 AH to 4.1 to 5 AH. And nominal voltage, if you talk about, nominal voltage is normally constant. Either we talk about 18650 or 21700, the nominal voltage is 3.6 volt. If we talk about the weight ranges from 48 gram to 70 gram. Internal resistance is again variable. It starts from 17 milliohm and can go as high as 30 milliohm in case of 21700 cells. And if I talk about the C rating, C rating, as we everyone knows, this is the charging, the discharging rating. At this signifies at what rate of the rated age we can charge the battery or we can discharge the battery. So if in NMC it could be point, it can be up from 0.2 C, and it can even go up to 1.5 to 2 C. Also it can go up to 2 C, and in critical condition it can withstand up to discharge discharging of 15 C. So typically if our cell is say 2.2 age of cell we are using. So if I talk about say 1 C, then we can if discharging C rating is 1 C, then that means we can extract 2 ampere out, 2.6 2.5 ampere out of that cell. And if you talk about say maximum 15 C, then it can be discharged at 15 ampere. And end voltage, if you talk about end voltage, it is the cutoff voltage at which below which it is not recommended that the cell should discharge below that voltage. So if we talk about NMC, it is 2.5 volt, and at standard 0.5 C, maximum it could be 2 C. And and if you talk about peak voltage is 4.2 volt for NMC cylindrical cells. Temperature, it could, charging temperature can go, it can be between 0 to 50, and discharging could be 20 to 75. The cycles of the cells vary from 300 cycles to 1000 cycles. Now, if you talk about the LFP cylindrical cells, LFP cylindrical cells are typically their dimension starts from 26650 to 32140. So, if I talk about 26650, then that means the diameter of the cell is 26 mm, and the length of the cell is 65 mm. And at the same time, the maximum it could go up to 32 mm of dia and 140 mm of length. Now again talking about these are the typical characteristics or features of LFP cylindrical cells. Typical capacity could be 3 H and could go as high as 15 H in case of 32140 cells. Nominal voltage is 3.2, which you could normally see that it is lower than the NMC cells. Weight, it could be range from 88 gram to 300 grams. Internal resistance 10 milliampere milliohm, sorry 10 milliohms to it could go as high as 16 to 20 milliohms. Discharge ratings, standard discharge ratings of 1 C, 0.5 C, and maximum it could be 20 C in case of 26650 HP cells. End voltage, it is standard end voltage or the lower cutoff voltage is 2 volt and at standard 1C discharging, and maximum it could be 3C, or it could maximum it could be 3C to 5C. And the peak voltage where it could be charged is 3.65 volt, and the charging temperature is variable between 0 to 50 and discharging between 20 to 60 cycles. You could see that these cells have better life cycles, which ranges from 2000 to 3000 cycles. So now if we compare between NMC and LFP cells, as I spoke in the earlier as I spoke earlier, that LFP are much latest technology, and they are found to be much safer cells than considered to NMC cells. So in latest technology, more of LFP cells are used in comparison to NMC cells. These are LFP prismatic cells. So now till now, the two versions that we saw were mostly the cylindrical type of cells. Now these are LFP prismatic cells. These prismatic cells hold much more capacity than the cylindrical cells that we spoke about. So typical the capacity could be from 40 Ah to 280 Ah in a single cell. Nominal voltage is again standard 3.2 volt. The dimensions could be vary as according to the age capacity, and so as the weight, which could start from 880 grams and it could go as high as 5.5 kg. The internal resistance would is also variable between lesser than 1 milliohm to lesser than 0.25 milliohm. Standard, these are at 0.5 C and discharge at 1C to 2C. And voltage again is 2 volt, but in some cases it is for a larger battery it is even 2.5 volt. At standard 0.5 C and maximum 1C. And voltage, the peak voltage, the maximum voltage that to which it could be charged is 3.65, and temperature 0 to 45 and discharging is between 20 to 55. Same, it has also larger number of cycles, which could go as high as 6000 cycles. So but in typically you would see that in case of prismatic cells, if we are assembling a battery, so we would be using lesser number, we would be the handling of cells would be lesser as in comparison to the number of the cylindrical cells. These are the pouch cells. Pouch cells, you would see that they are mostly used in the electronic items, mostly in laptops and in the mobiles. So these are the features of pouch cells. Typical capacity is 25 or 33 Ah at 0.2 C, and nominal voltage is 3.2 volt. Dimensions could vary depending upon the size of the battery, so as the weight, and internal resistance would also vary as according to the capacity. And discharge, if you see standard 0.5 C, continuous discharge, it could take up to 3C continuous discharge it could take, and voltage is 2.5 volt to even lesser, it could go as low as 2 volt also. And if you talk about the peak voltage, it is 3.65 volt. Charging temperature is between 0 to 45 and it is between minus 10 to 50 degree, and discharge is 20 to 60 and it is minus 20 to 55. The cycles are also like variable depending upon the battery. It could start from 3500 cycles and go as high as 6000 cycles. So now going to the basics, the cells are combined to form a module, and module is combined again to form a battery pack. So here in the slide you can very well see that there are cells. These cells could be cylindrical or prismatic. They are combined in series or parallel according to the requirement, the capacity of battery that we want to make. So accordingly they are combined and we form a modules, and those modules are again connected in series or parallel, and then a battery is formed. So there could be a general question that why we form a module, and like what is the basic use of module. So if in case of batteries, when we have to handle a large lot many cells, when the number of cells are very large, we form modules, and those modules are then connected in series with the BMS. So one advantage that we get with the module is that if we have some a cell malfunctioning in the module, instead of replacing the entire battery, we can replace that module, or it is very easy for us to identify the faulty cells. So larger batteries are normally broken into modules, and then those modules are again combined to form a battery pack. So if you talk about a typical battery pack, this is a basic battery pack, the basic components that the battery pack has. So it would have a casing, outer casing. It could be made up of plastic, or it could be mostly it is made up of iron or steel, so as to so that it is in case of any damage that occurs, internal damage that occurs into the battery, then it takes care of that. And mostly these enclosures are IP67. IP67 is a general standard which says that our battery is dust free and waterproof. So in any case, if we leave that there is rain, or there is it comes into contact with water, there are very less chances that the water will seep into the battery. And then we have the cells, the combination of battery, as we said, that is made up of cells. So these cells are held by holders. So these are plastic holders that separate the cells. So in any case, if there are some cells that are heating up, so or when the vehicle is moving, due to the vibration, these cell holders will hold the cell and will not allow two cells to touch each other. And these cells are connected with each other through nickel strips. So with the help of the spot welding, these cells are connected in series and parallel, and we use the nickel strips to connect them. And the cell, then there is BMS into the battery. BMS is the battery management system, which takes care of which also is the brain of the battery, which decides when the battery needs charging and to what extent it has to be discharged. And it also monitors the battery temperature and the balancing of the cells. So if any malfunctioning, or if there are any over voltage or over current happening into the battery, the BMS will take care of it, and it will disconnect the battery from the load. So a basic idea about like battery pack designing. When we are going for a battery pack designing, first and foremost thing that we have to take care of is, first we have to determine the what capacity, that is what age and what voltage battery we are supposed to design. After knowing that, we need if cylindrical or the prismatic cells, whatever we want for our battery, we have to arrange those, and we have to arrange those. And before combining them into modules, we have to make sure that those all cells are at the same voltage, because uh, so when we go for spot welding, before going for the spot welding, we have to make sure that all the cells are at the same voltage. So this would assure that we are going for a balanced battery, because if once we have welded, we have formed a battery pack, and if cells are at if cells are at variable voltages, different voltages, then that would not give us the desired capacity that we want. After the with the help of the cells, and we form the modules, and those modules we arrange in series or parallel to get the desired capacity and the voltage. And these modules are then connected with a BMS, which monitors the entire battery. So a small example, if you want to say, if you want to we are designing a battery pack of 72 volt with capacity of 41.6 Ah with NMC cells of individual cell capacity of 2600 mAh and nominal voltage 3.6 volt. Then first of all, let's find out that for 72 volts how many cells we would need to arrange in the series. So it would be 72 divided by 3.6. So 20 cells we have to arrange in series, and to get the desired capacity, that is 41.6 Ah, we have to arrange this set of 20 into parallel. So we would need 41.6 divided by 2.6, that is 16 parallel different 16 modules we would need. So cells of 20 modules, cells of 20 cells connected in series of, and 16 of those we would need to form a battery of 72 volt and 41.6 Ah. So total number of cells that would be needed to form to make this battery would be 20 into 16, that is 320 cells we would need to make this battery. We will take one more example in which we will design a cycle battery pack of 25.2 volt 10.2 Ah and with NMC cells of individual cell capacity of 2550 mAh and nominal voltage 3.6 volt. So first we have to determine and place the cells in series so that we could get 25.2 volts. So we see that 25.2 divided by 3.6, when we place 7 cells in series, we get the desirable voltage of 25.2 volt. Now we'll find how many cells we have to place, how many lines we have to place in parallel to get the desired capacity of 10.2 Ah. So here we see 10.2 divided by 2.55, that is 4. So 7 cells in series and 4 in parallel, we get the desired capacity of 25.2 volts and 10.2 Ah. So total number of cells that we will require for this uh, battery would be 28 cells. So with 28 cells, with 7 placed in series and 4 sets placed in parallel, we'll get the desired capacity. And if we talk about the total capacity of the battery pack, then it would be Ah multiplied by the voltage, which is 10.2 into 25.2. So it is 257 watt hour is the battery capacity.